Okay, so we are looking at factoring today. No new methods. Nothing is new. All that you might have is more variables or higher degree. So take a look at the first one here. This is the easy, simple trinomial. No work required. So do that right now. Two numbers that multiply to negative 54, add to negative 3. Get out your calculator if you need to. Find factors of 54. Okay, hands up. Who has that factor? You can tell me what it is back. William? Good. X plus 6, x minus 9. Take a look at this. The only difference is that, so we've got all the same coefficients, but now we have an xy term and a y squared term. We factor it the same way, but it's going to have our second terms being y terms. So I want you to expand this back. I'm actually telling you what the answer is. If you expand this back, you get x squared minus 9, minus 9xy plus 6xy, which gives you that negative 3xy term. And then minus 54y squared. So you still follow the same procedure, no work required because it's a simple trinomial. And you need two numbers that multiply to negative 54, add to negative 3. But now instead of just constant terms, they're going to have y's with them. Okay, that's the only difference. So same with the next one. Oops. Take a look. You decide which method you use. It's not a simple trinomial. It's got a 2 in front. So if you use inspection or decomposition, however you get that, give the answer to that one. I'll give you a minute to do that. Who's got the factored form for that? Tolu? Okay, so that looks good. Okay, you can use decomposition, you can do trial and error, but you can always check by expanding back. Is that a hand up or you're good? Okay. So only thing different here, notice the coefficients are exactly the same, but now we have an xy and a y squared. So the outer terms are both variables squared, and the inside term is one of each. So the only difference here would be the second term in each will be a y term. So 2x minus 1y, or just y, and x minus 3y. Okay. Maybe I'll show you just here, I'll show you if you were to do this by decomposition, how it would look when you have that both variables in it. So decomposition, we would have decomposed the middle term into minus 6xy minus xy plus 3y squared. Then when we factor by grouping, we'd factor out the 2x. We'd be left with x minus 3y. And then we factor out a negative y, and we'd be left with x minus 3y. And so you can see it works its way through. That's why decomposition is the sort of the full mathematical way of doing it. Remember, it doesn't matter which order the brackets are in, but that would be how the y's stay within it. But you don't have to show that work. You can just use inspection and go right to the final answer. Okay, so that's with two variables. So it says now you have now learned several different methods of factoring and now need to be able to determine which method to use when given an expression to factor. Here's strategies that are helpful. Always look for the greatest common factor first. Okay, if you don't, and you could still factor, but at the end there would within the brackets be something that you could factor out, so it would not be considered fully factored. Then if it's two terms, remember we learned that on Thursday, see if it's a difference of squares. If it's three terms, see if it's in this form, right? And that really covers the fact that maybe you have x's and y's in it, or higher degree. And then always look at your factors to see if you can factor again. Okay, and that's why we say factor. So we're not always going to remind you to factor completely. It's when you're asked to factor, it means factor completely, right? So take a look at this next one here. It's got an x cubed, x squared, x. Well, that's not really of the form that we know how to factor right away. It is a trinomial. So look for a common factor. Who can tell me what the greatest common factor of that is? 4x. So when we factor out the 4x, we're left with x squared plus 2x plus, minus 3. Okay, and then that's a simple trinomial. So you can set up your brackets with x as the first term right away. And then you're looking for two numbers that multiply to -3, add to 2. So that would be +3 and -1. Okay, so greatest common factor first, then see if you can factor within the brackets. Next one is a little bit crazy, but not too bad. Take a look. We've done some with two brackets in the expression, and we factored out the brackets. This has 3 sets of brackets. Biggest thing, look to see if the brackets are the same. Is everything inside those brackets exactly the same? So yeah, it is. If it wasn't, then you couldn't factor them out. Probably you want to expand, which would be quite messy in terms of how many terms and degree. So that would make it more challenging. So this one, we want to factor out our greatest common factor, right, which is the x squared minus 1. So now that factors out, and we're left with 6x squared plus 11x minus 10. So in our second bracket, we actually have a trinomial. Okay, so always check your brackets. Take a look at the first one, x squared minus 1. Can that be factored again? Sure can. Thursday's work. It's a difference of squares. Okay, so that can be factored to 2 binomials. The root of x squared is x. The root of 1 is 1. 1 has a plus, 1 has a minus. Did that on Thursday. Okay. Next one, can it be factored again? Well, I do have to check. I put the brackets, but I need to check. Are there two numbers that multiply to -60 and add to 11? Yep. Who can tell me what those two numbers are? Vincent. Good. +15, -4. There we go. So do I put 6x and x here? Nope, because I have to get on my outside and my inside 15 or -4, and I can't. So the only other choice is 2x and 3x. So I'm using inspection. And then now 2 doesn't go into 15, so my outside here has to give me -4. So that would be -2 there. And my inside has to give me 15, so that would be +5. Okay, so that factors to 4 brackets. Another one, so as I said, I want to do a few from the practice part of this. I want to give you a look actually at the page. Maybe it's too many. Wait 1 second here. Okay, so we're going to flip over to question number 2 and do a couple of those together. There we go. What ones do I want to do? Okay, so let's take a look at question number 2. Let's take a look at H and J and L. Well, we'll do those 3 to start. So first one is a non-simple trinomial. What you want to notice, again, from Thursday's work is take a look. If the first term is a perfect square, right, that the square root of 100x squared is 10x. Square root of 9 is 3. Remember our fast way of checking, if the product of these together doubled is 60, right, times 2 is 60, then this is a perfect square trinomial. And it can factor to a binomial square, where the first term is the root of the first term, and the last term is the root of the last term, and the sign, whatever's in front of the 60, is the sign that goes in there. So didn't have to do any work, didn't really have to do a lot of trial and error. It was just noticing that it was a perfect square trinomial. Okay. So that was from Thursday. Okay, J, can't factor it the way it is. What's common though? What's a common factor for all the 3 terms? Pardon? 3a, good. Yep, so we're going to factor out 3a, and we're left with a squared plus 3a minus 40. Then it's actually a simple trinomial, so it's quite easy to factor this one. A goes at the beginning of each. We need 2 numbers that multiply to -40, add to 3, so that would be 8 and -5. Okay. Now take a look at L. It's 3 terms, right? Is there a common factor to all 3 terms? No. So then you have to think, okay, is there a way I could factor this using a similar method to what I've done for other trinomials? The other ones we've done have been x squared x and constant, or x squared xy and y squared. This is y to the 4th. But if you think about if we set up 2 brackets and had something y squared at the beginning, when you would expand this back, you get y to the fourth. Then your outside would be y squared, inside y squared, which would give you a middle term, and then your constant term. So if it's a y to the fourth, y squared and constant, so trinomial, but degree 4, degree 2, degree 0, then you do the same method except you're going to have y squared as your first term. So now we need two numbers that multiply to negative 60 and add to 7. Okay, so we multiply to negative 60 and add, sorry, everything's slow, add to 7. So what two numbers work for that one? Factors of 60. So 1 and 60, no. 2 and 30, no. Negative 5 and positive 12, yeah. Okay, so here we have to think about it. So we could have, our first term is 6, so we can try 6 and 1 because we have a 12 here. 6 goes into that. If it didn't go into either of those, then we'd split it up into 2 and 3. But 6 works, and then our outside then would have to be get us 12, so that would have to be plus 2, and our inside would have to be minus 5. So then when you expand it back, you get the original. Now I'm just going to tidy this up a little bit because I didn't really need to have a space in front of the y squared there. So I'm just going to make that bigger and that like that. Okay. So if it's y to the fourth, y squared and constant, or x to the fourth, x squared and constant, you're going to have terms that have a squared in it. Always take a look at what's left there. Are they a difference of squares? Well, because the first term here is a y squared, but it's not a difference, it's a plus, and 2 isn't a perfect square. So we can't factor that again. Okay, so that's one like that. Let's take a look at, let's go down here to W. That's a big one. W and X. Okay, so kind of like the one we did in the lesson part of this, the brackets are exactly the same. So if I factor out x squared minus 9, I'm left with, notice how it's a different variable, 2y squared plus 7y plus 3. Now, can you factor again? So x squared minus 9, that's a perfect difference of perfect squares. So you can factor that to do two sets of brackets. And then the second trinomial is also factorable into two sets of brackets. So I'll give you a minute to work on that. Yeah. Only choice for the first terms from the trinomial are 2y and y, because 2 is a prime number. Two numbers that multiply to 6, add to 7 are 6 and 1. So that would have to be plus 3 plus 1. Okay. Only way of checking this is expanding out everything, including the original. So you know how we always say factoring is the opposite of simplifying. So if you want to simplify the factored form, that's one way of checking. The problem is in the question that was given to you, it wasn't in simplified form and it wasn't in factored form. So you have to basically simplify both if you wanted to check properly. Okay. Next one, take a look. Brackets are the same again. So if I factor out t minus 5, I'm left with 4t squared minus 1. It's understood to be a 1 there. Okay, and the second bracket is a difference of squares. It's a binomial, it's a subtraction, and both terms are perfect squares. So 2t, 2t, one has a plus, one has a minus 1. And then I think we're going to do this y here. Yeah? Okay, so in y, it's really two terms. So don't expand it out. It'll be way too complicated. Here, this is one term. Here, this is the other. So it's two terms and it's a difference, but they're not perfect squares right now. Yeah, we have a factor that's squared, but 2 isn't a perfect square, neither is 72. But notice that they're both even numbers. So I can factor out a 2. So I'm common factoring. And I'm left with, I'm going to use big brackets and then show what I'm left with inside there. So 72 divided by 2 is 36. Okay. So I factored out a 2 from both terms. Now within that square bracket, it's a difference of perfect squares. Anytime there's something squared, okay, anytime there's something squared, you know it's a perfect square, and 36 is as well. So when I factor this, I'm going to actually now show it two sets of square brackets, where I take the root of the first term, which will be one of the brackets. I'll just keep it in there for now. Okay, and then the 6 goes at the end. One has a plus, one has a minus. Right now, if I get rid of the inside brackets, nothing's going to change because they're the first term, right? And there's no like terms in there. If that wasn't the case, say if the inside bracket was, the round brackets was x squared plus 5, and then you're adding 6, you'd want to simplify those. But they're not like terms. So really what this looks like is two trinomials nothing really changes when I get rid of the inside brackets. But in those trinomials, you want to see if you can factor again. So are there two numbers that multiply to 6 and add to 5? Yep, there are. So you think about those. And are there two numbers that multiply to negative 6 and add to 5? 3 and 2 is the first set. And then the second set is 6 and negative 1. Okay. Sometimes you have to factor lots.